Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics, thermodynamics. The topic discussed is Carnot engine part 3, derivation of expression for efficiency of Carnot cycle. Why is Carnot cycle not feasible? We will give the reason for that. Please watch the video completely without skipping, and if you think the video is useful, do like the video. Share the video with your friends who may also be benefited, and also leave your feedbacks as comments in the comment box below. If you are watching without subscribing my channel, do subscribe it now and also press the bell button and all button for notification of more videos like this. Thank you very much for your support. Come, let us discuss that topic. As you already know, the Carnot engine works between two temperatures. T1, the temperature of the source, and T2, the temperature of the sink. T1 is infinitely high and T2 is infinitely low. The working substance is ideal gas. It is claimed that the efficiency of Carnot engine is 100%. We know that Carnot engine is only a hypothetical engine. Such an engine is not possible in reality. We will derive an expression for calculating efficiency of Carnot engine and then proceed to say why Carnot engine is not feasible. That is, it does not exist in reality. It is only hypothetical. I have carried over these two formulae from the previous video. We need it here. We need the expression for Q1 and Q2. If you have not watched my video on work done for Carnot engine, please click the I button in order to watch that. Work done 1 to 2 is equal to Q1 and it is equation 1. Work done 3 to 4 is equal to Q2. You have a negative sign there. Negative nRT2 natural log V4 by V3. We remove the negative sign and write it as nRT2 natural log V3 by V4. That is equation 2. We already have the formula for efficiency. Efficiency eta is equal to 1 minus Q2 by Q1. I have already posted a video on efficiency of heat engine. If you have not watched that video, please click the I button in order to watch that. Here, what we need to do is only substitute for Q2 and Q1. That is 1 minus equation 2 by equation 1. That will be equal to 1 minus nRT1 natural log V2 by V1 divided by nRT2 natural log V3 by V4. This nr and this nr will get cancelled. Then it becomes 1 minus T1 natural log V2 by V1 divided by T2 natural log V3 by V4. Now we have to see how this V2 by V1 and V3 by V4 are related. For that, we will just recall the PV diagram for Carnot cycle. I will represent the graphical representation for all the 4 processes taking place here. We will also mark the points 1, 2, 3 and 4 and the corresponding state functions at each point. Okay. We have to show that V2 by V1 is equal to V3 by V4. So we need a few steps. For the examination, you need write only V2 by V1 is equal to V3 by V4. So it can be cancelled. But we should convince ourselves that V2 by V1 is equal to V3 by V4. For that, we have to consider a few steps. Let us continue. From the graph, you can see P1 V1 and P2 V2 lie on the same isotherm. P1 decreases to P2 and V1 increases to V2. Therefore, P1 V1 is equal to P2 V2. Temperature is constant. I will note down the reason why P1 V1 is equal to P2 V2. For the second step, that is adiabatic expansion work, P2 V2 raised to gamma is equal to P3 V3 raised to gamma. Gamma, you know, is the ratio of the specific heat capacities of the gas at constant pressure and volume. From the graph, you can notice that P2 V2 and P3 V3 lie on the same adiabat. For the next step, P3 V3 is equal to P4 V4 because they lie on the same isotherm. And for the last step, P4 V4 raised to gamma is equal to P1 V1 raised to gamma because they lie on the same adiabat. Now we have four equations here. The product of the left hand side of these four equations will be equal to the product of the right hand side of these equations. P1 V1 into P2 V2 raised to gamma into P3 V3 into P4 V4 raised to gamma is equal to P2 V2 into P3 V3 raised to gamma into P4 V4 into P1 V1 raised to gamma. P1, P2, P3 and P4 are common on left hand side and right hand side. So those quantities can be cancelled. What remains on the left hand side is V1, V2 raised to gamma, V3, V4 raised to gamma. And on the right hand side, V2, V3 raised to gamma, V4, V1 raised to gamma. I will move on to the next page. So what remains here is V1 into V2 raised to gamma into V3 into V4 raised to gamma is equal to V1 raised to gamma into V2 into V3 raised to gamma into V4. V1 on the left hand side, V1 raised to gamma on the right hand side. On the left hand side, V2 raised to gamma, but on the right hand side there is only V2. On the left hand side there is V3. On the right hand side it is V3 raised to gamma. On the left hand side there is V4 raised to gamma. On the right hand side there is V4 only. These quantities can be suitably combined and written as V2 raised to gamma minus 1, considering V2 on the right hand side, into V4 raised to gamma minus 1, considering V4 on the right hand side, is equal to V1 raised to gamma minus 1, considering V1 on the left hand side, into V3 raised to gamma minus 1. This can be further simplified as V2 into V4 the whole raised to gamma minus 1 is equal to V1 into V3 the whole raised to gamma minus 1. When we compare the left hand side and right hand side, you find gamma minus 1 on both sides. So it gets cancelled. So the equation becomes V2 into V4 is equal to V1 into V3. From this, we can get the expression V2 by V1 is equal to V3 by V4. So, we have found the relation between V2 by V1 and V3 by V4. They are equal. So, natural log V2 by V1 is equal to natural log V3 by V4. We have obtained the relation efficiency eta is equal to 1 minus T2 into natural log V2 by V1 divided by T1 natural log V3 by V4. When we apply this, natural log V2 by V1 and natural log V3 by V4 get cancelled. So efficiency eta is equal to 1 minus T2 by T1. So we have derived an equation to calculate the efficiency of Carnot engine. What do we understand from this equation? We understand that efficiency of Carnot engine does not depend upon the working substance. It depends only on temperature of the sink and the source. Carnot engine envisages the temperatures T2 and T1 at infinity. Therefore, efficiency is assumed to be 1, that is 100%. Can we design a Carnot engine in reality? Is it feasible? But in real conditions, we cannot assume T2 to be infinitely low, nor can we consider T1 infinitely high. Therefore, T2 by T1 has some value. Therefore, efficiency will be less than 1. So, it is not possible to design an engine like Carnot engine in reality. So, it is only a hypothetical engine. I hope it is clear. I hope this video was of great use to you. If you think it was useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now, and also press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video with another important topic like this. Till then, bye. Take care.